In this video, you will learn to identify if a relationship is proportional or non-proportional. Here's the definition of a directly proportional relationship. A relationship is directly proportional if it has two things. It needs to be linear, and it also needs to have a y-intercept of 0. Let's look at these equations and see if they are proportional. Starting with this one, y equals negative 4x plus 5. I know it's linear because it's in the form of y equals mx plus b. When I check the y-intercept, I can see that it has a y-intercept of 5. So it does not have a y-intercept of 0. So this one is not. With the blue one, y equals half x. That one is also linear. Half is my slope. My y-intercept is 0 because I could write it as plus 0. So since it's linear and it has the y-intercept, this one is proportional. The green one, y equals 1000 plus 20x. I know it's linear because it has the slope and a y-intercept, but the y-intercept is not 0, so this one is not. Y equals negative 50x. Has a slope, so I know it's linear, and the y-intercept is 0. I could write it like this. So this one is proportional. And the final one, x times y equals 30. This one is an inverse relationship. So right away I know it's not linear, so it's not going to be proportional. From a graph, it's pretty easy to see. I look first to see is it a line, and then I look to see if the line goes through the origin, or 0, 0. So looking at this first graph, I can see that it's linear, it's a straight line, and then the y-intercept is right there. The y-intercept isn't at 0, 0, so this is not proportional. On the second one, I can see it's linear right away. Here's my y-intercept. It goes through the point 0, 0, which is the origin, so it has a y-intercept of 0. So this one is proportional. Just think really quick in your head, which is proportional, which one is not proportional. Hopefully you said the first one is proportional because it's linear and it has a y-intercept of 0. The second one is not proportional. It is linear, but the y-intercept is at 3. When I have a table, I need to check to see if it's linear and then look at the y-intercept. So with the first table, I can see that in the x, it's going up by 1 each time. So let's see if we have a constant rate of change in the y's. Each time, it is going up by 18. So that means I have a slope of 18, and so it is linear. My y-intercept is 0, 0. So it's linear, has a y-intercept of 0. That makes this table and this relationship proportional. The second table. Look to see, is it linear? Going up by 1s in the x. The y's also going up at a constant rate of 2. So I have a slope of 2, making it linear. And let's look at the y-intercept. Here it is, 0, 10. So it does not go through 0, 0, which means that this one is not a proportional relationship. And the final table. X is going up by 1s at a constant rate. Y's also going up at a constant rate of 12, so it is linear. This one I don't know the y-intercept right away, but I can work backwards to 0. And then if I work backwards in the y, I'd be taking away 12. So my y-intercept would be at 0, 0. So that means that it's linear has a y-intercept of 0, 0, which makes it proportional.